All right, so I think this should be the last video. So we've successfully built the model. We've now run it, and now let's look at the results. So there's two ways we're going to look at the results. The first way will be kind of the way that is the most common way of doing it, and this is using a graphic post processor, a visualizer. In this case, it's going to be Hyper-View. But for 1D elements, you'll find that sometimes it's hard to see all the information that you want in there. And so we'll also look at the actual number values of the output results in the opti file. So we'll do both of those. So first, we're going to, once you get this screen and you have no error messages, you can hit the results button here. When you do that, it will automatically load Hyper-View. And here it's loading, and I'll have to get it to be on the little window screen. You can see parts of it. Let me just adjust the window. All right, so there we go. Okay, so here you can see it's a bit of a different interface. It's a different application, but it's also Altair program. So here you can see our truss model, right? I can spin it around. And now we can look at the results. Over here on the left, you can see a lot of the things like that were in the model view in Hyper Mesh. So for example, I don't know if they show. We have different load cases here. I guess that's it. Okay, so if you had different components, you could turn on and off different components, but we only have one, so it's kind of silly to turn it off. So we'll leave it there. And then up here, you can see we have the two different load cases. So subcase 1 and subcase 2. So first, we're going to look at the horizontal load case. All right. So what we're going to want to see here is we can look at the displacements. We can deform it and look at like a little animation of those displacements. And we'll also want to see the element stresses, okay? So to do the displacements, you're going to click on this little icon here on this band of icons just below the graphics window. So it looks like a deformed beam, sort of. So we click that, and that allows you to pick different deformations. So we're going to use the displacement, and if you hit apply, you'll see that it doesn't really do much. And that's because the displacements are typically very small. They're nowhere near the order of 4 feet. So you usually want to scale them. So you can see there's a scaling factor here. So right now it's set to 1. So I think if you set it like 250 times, you'll see, okay, so now I can see something that looks like, something that makes sense. That is interesting. Is that really the way it's supposed to be? Okay. I think there's something weird here. Okay. Okay. Let me double check. I have a feeling that. Okay, whatever. Let's just go with it for now. I think there's a mistake here. But we'll see. Okay. Because that might be right. Okay. So, all right, forget what I just said. So we set a scale factor to 250. We applied. And then you can see this little slider button here, kind of like slides it from no deformation to full up deformation. You can also animate it by hitting the little play button, and it does it at a ridiculously high speed. I don't know why it does that. And so if you could slide this bottom slider down, it changes the playback speed. And so that's useful. No, I think this is right. Okay. And you can actually change this button here, and it'll do a couple different modes. Like it looks like this one oscillates between positive and negative, like we're doing a vibration. But for us, the good one is transient animation mode. This is a good one, right? What happened? Right, linear animation mode. That's one, right? So that looks good. So you can also show the undeformed shape. Right now here, this little window, it says undeformed shape, and it shows none. So we can change that to wireframe. And now you can see the wireframe. Maybe it's a little confusing because you have the same color for both, so we can change the color. I think we can change it here if we do it this way. Can you change it? Yeah, you can change it to like a gray, something gray, so it's not quite as obvious, right? So it looks, yeah, and so there you can see that. So that's good. We've seen the displacements. Maybe we don't want to animate it anymore. We're just going to look at we just put it into its max displacement. But now we also want to see the element stresses. So to do that, we want to color each element with a corresponding color associated with its stress. So to do that, we're going to pick this little button here, again, below the main graphics window. It looks like a flag with like the colors of the rainbow spectrum. And we're going to pick that. And this will tell you what we want to color the elements by. So right now it's set to displacement. You can hit apply, and it's shading them with the displacement results. Okay. But most of the time we're going to pick like stresses. So we'll pick the stresses, and this will give us the axial stresses, and then we can hit apply. And there you go. And so you can see in this case, it gives us the axial stress for the top two elements, and then pretty much we get 0 everywhere else. Okay? Now, we can look at the same plot, and we can change it from load case 1 to load case 2 just by going here to the upper left portion and selecting subcase, the download case out of that. And here you can see it looks quite a bit different because we have the downforce, right? So maybe that one, there's more displacement there, so I probably could scale that back, but, there it is. And when we do that, you can see we have different element stresses according to the legend on those, all right? All right, and there's a lot more things you can do. It's actually really nice. You can actually import videos of tests and show them side by side, and it's really a very nice post processor. Okay, so that's the conventional way of looking at your results. And if you want to export these things for like presentations, you can go up here to this little area here, and you can do like a screen capture. And this is nice because when it does it, it'll I'm going to just do it here. You'll see it makes like a nice white background, so you can put it into a document. I'll call it results 1, right? And I think it did it. So yeah, if we open that up, yeah, you see, it puts it on a white background, so it's easier to see, right? So it's good for putting it into a document. All right. You can also output a movie. So if we pick like movie, I think this will make a movie like an AVI file. It's kind of old. It doesn't have MP4s, but you can do it as an AVI. Will work, okay? But you can save the movie there as well. Okay. Okay, so that's like the normal way we do it. We also will want, for 1D elements, like I said, it's convenient to actually look at the opti files that are getting written out. So, we're done with this. So I'm going to just close this. It'll ask me if I want to save the session. You can, and then it'll just save it to exactly the same state. So I'll do that. But you don't have to do that. And then, the results are still on your disk, right? Maybe before I start, we'll show you where the results are too. So we don't need this anymore too. That's just the solve menu. And okay, so let's go look at the files that it created. And I know you don't get, I'm going to try to clean it up a little bit so you don't get confusing. So here's the directory where I ran everything. And so you can see some of the files are like I used for making the PDF of the assignment, but don't worry about those. But you can see here's the model file, the hypermesh file, truss2.hm. Here's the MVW file is the one that Hyperview saves, the one we just saved. And the finite element input file, the one that gets read by OptiStruct, is this one that's called .fem. So we can open that up like in a text editor, like Visual Studio Code I use, right? And here, right, you can see is the actual ASCII input file, right? You can see here are the forces defined. One's on set 2, the other 2 are on set 3, and you can look at all that stuff. Here are the elements, the properties, whatever, right? So that's all good. That's useful sometimes to edit. But then we're also going to have the output file. So you can see we have one that's a truss2.displacement, SPCF, STRS, and force. So those are the 4 that have the results. So like if we look at the displacement results, so we'll do truss2 displacement. Again, you can open them up with Visual Studio Code, VS Code. And so here you go. So here are the displacements. For each node, there's 5 nodes. This is for load case 1, and this is for load case 2. And you can see we have each column, there's the 3 translations, X, Y, and Z. Those are the first 3 columns. And the second 3 columns are the rotations. So you can look up and exactly see what's the displacement of node 2 if you want, or for load case 2, what's the displacement of node 3. All right. Now where this will be important is when we talk about the element forces, because we'll need these to back out the torsional stresses in some examples. So if we look under the one that has an extension .force, it has another format that's got the forces, again, 2 load cases, 6 elements, and then the axial force at node A and B, the first and second node, and also the torque. Okay. So you can look at all these. Here's the reaction forces. Whoops. I don't want to do this. Oh, why are we doing that? I didn't mean to click on that. I'm going to open it with code. And there they are, okay? So if you want to look at the actual formats of those, this is what I did not go over in class, but if you go to the slides for the C-rod element, down here, right, the last 3 slides tell you what's the format of those Opti files, so you can figure out what the displacements are and all that sort of stuff. Okay, so there'll be some homework assignments where you'll need to do that, and so use this file to figure out what is what. Okay, it's not that hard, but it's good to know with confidence what it is you're doing. Okay, all right. So I think that's pretty much it. So we've done quite a bit here, and we've seen a lot of the major options that we use in this class for doing this stuff in Hypermesh. So hopefully it worked out well. If you do get an error, just back up the videos and see if you can see where. If you can't, then send me a message through Teams, but please include the actual error that you get in the message window. And I'm sure if I see that, usually I can tell you in a minute what's supposed to happen. Okay, so that's it. So good luck.